Hi everyone, I am currently working on writing an article about the quality of math education in our schools. So I thought, since you guys are students, you might be interested in a little rant I have about math education. As a disclaimer, this video is not meant to be talking about any specific teachers or any specific classes, more about the quality of the textbooks and the curriculum in general. So I guess I'll start with a bit of background. Um, So, pretty historically, people have believed for at least about 100 years now that math education is bad, as in, students don't like it, we're not learning anything. It's debatable whether most of this is really useful. After all, if students are forgetting like 90% of what they learn in math class, and as long as they don't go into a field such as engineering or any field that requires these specific formulas, they're pretty good at functioning without them. But anyway, the main problem with education reform is obviously that you have to get the government and you have to get a large group of people who are pretty used to sticking with the traditional norms to change, and that is very difficult. So the first math education reform came in about the 1950s and 60s, when Russia had just launched the Sputnik into space, which had convinced America, basically, that Russia had a better math and science program than America, and America needed to be more competitive and do so by improving math education. So it began to be able to be a bit more accepting towards and pay a bit more towards the math reforms. So there was a new reform called School Mathematics Study Group. And their goal basically was that they thought that the current math, what people are teaching, was, well, basically pretty much useless. And I don't know if I agree with them or not, but that is what they claimed. One of the evidence I found that people were talking about was the idea of solving a triangle using trigonometry was originally placed there when one of the biggest careers that people were having was surveying and map making, and you would need to solve a triangle in order to find the different lengths and angles and sides that you would need when you are surveying or map making, as in the practice problems you've seen where people are trying to measure the length of a lake, for example. And they're basically arguing that no one really uses this anymore. It's a very minor career, and if people are going into those specialized careers, they can learn about these topics when they enter into those careers instead of having the entire group as a whole learn this. Again, I'm not entirely sure whether I agree with this or what concepts I believe should be taught in math education. I do believe that math should be taught. I'm not sure entirely my personal reasoning about what is important to be taught in math. But anyway, this is what the School Mathematics Study Group believed, and they wanted students to learn abstract math, which was more like logic, symbolic logic, reasoning, ideas of fields and types of numbers, the difference between like a real number and a real number, an imaginary number, integers versus natural numbers, those sorts of things. And this went on for about 15 years. Then a book was published called Why Johnny Can't Add. And this was basically one of the biggest damning pieces against the School Mathematics Study Group, after which the general public believed that the math reform wasn't working, and they went back to the more traditional curriculum. The book Why Johnny Can't Add was generally arguing that teaching kids analytic geometry was, well, agreeing that the traditional math curriculum was bad, but also was arguing that teaching kids not analytic geometry, abstract math, was equivalently useless, and that students wouldn't really be able to understand symbolic logic, that they needed concrete examples to help them. And usually when you do end up teaching things like symbolic logic, you do so by starting with real world examples. You say, all crows are black is not the same thing as saying that all black things are crows. And you teach them using real world examples. So if you are saying that this mathematical thing teaches them how to use logic in the real world, it doesn't seem to work that way. It seems more like people's natural aptitude for logic in the real world teaches them about logic in math. And after that, people went back, I believe, to the more traditional mathematics curriculum, though don't take my word for that completely because I'm not entirely sure. But in 2002, Paul Lockhart wrote a paper called Lockhart's Lament, talking about basically how students are taught math as a series of cold, dry formulas, where they're not really taught to understand why the formulas came about, what the historical significance was, who discovered it, what process did they go through, why does it work, are there alternatives, did people fight that? It just, here's the fact, memorize this fact. And this was published in 2009, and people with beliefs such as these were able to eventually pass the new Common Core curriculum, which may seem strange. It seemed strange to me when I found out about it, because I personally have been taught by the Common Core curriculum, and I don't think it's working. And that's one of the things that was the most surprising to me when I read about this, was that the Common Core curriculum, what people are saying about the Common Core curriculum being the triumph of math reform so far, it really doesn't look like it's improved that much. So I don't know what has happened between the passing of the Common Core curriculum, which from what I have seen, the people who passed it and the standards they were looking to get passed do seem to be more of a what I would consider a better math education, where people are taught to understand what they're going through and be able to think critically and solve problems that aren't just, here's a formula, plug in the formula. But one of the things that I have heard is that a lot of the textbooks that people use for Common Core aren't actually fitting to the Common Core standards. There's a website that I will link. I will link a lot of websites actually in the description. But there's a website that I can link that talks about how a lot of the Common Core textbooks just don't fit the Common Core standards, because the problem is that there's no requirement for the textbooks to meet the Common Core standards in order to say that they are Common Core books. They can write that they're Common Core books without actually being Common Core. So that is one of the problems. So that brings us to today. And today I am going to list out my problems that I find in the current math education system. So I think one of the more specific examples that models why I don't like this textbook or this curriculum is section 4.5 of our pre-calc textbook, which talks about exponential and logarithmic functions. So it gives this model of population growth. We're talking about the formula n of t equals n base 0 times e to the rt. And it gives you all these numbers where you plug them into the formula. And while it gives about maybe a quarter of a page of an explanation as to why this is, it sort of gives a very brief explanation as to why the population growth is the way it is, without really connecting it too much as sort of giving one example of how this works. And then going straight into, actually we're going to use E because calculus, and just generally just giving you this formula without actually showing why you use the formula. Then instead of explaining how to understand this formula, how you can think about it to make it seem more relevant or easier to use, you just sort of go into a bunch of different examples of using the formula, where basically the idea is you memorize the formula and you plug in numbers. And then you go into a different example, and again you're memorizing the formula, and then you plug in numbers. And then you go into a different example, and again you're memorizing the formula, and you're plugging in numbers. And suddenly you've passed through 4 pages of different examples of simply plugging in numbers to this formula that you have memorized. And my point here is that my personal belief is that you could have spent these 5 pages explaining why this formula is the way it is. How do you understand this formula? How do you visualize it? Why does it make sense? And then obviously if it makes sense to you, you're going to be able to use it a lot easier than if you're just given this formula that doesn't really make any sense, but you're just told, here, you have to memorize this now, have fun. And they do this for so much of the textbook, where it's just, they throw formulas at you, then they throw examples, where instead of spending the time trying to explain the formula, or why it makes sense, or what it's really talking about, they're just like, here, let's practice plugging in numbers. And then you get the homework, and it's 100 problems of just plugging in numbers, and plugging in more numbers, and plugging in numbers that are gross and ugly and have tons of decimals, and you have to double check them 3 times using a calculator, because you know because it's really easy to make a calculation error somewhere when you have like 20 decimal places. And instead of just understanding the concept, you're understanding how to plug in numbers into a calculator and trying not to enter in a wrong number 5 places after the decimal point. And this is, not only does it not teach you math, it's just teaching you formulas, it makes it really difficult for anyone to understand anything. Like, one of the reasons that I usually don't need to study for math tests is that half of these formulas I have not memorized. I haven't memorized the half angle formula, I haven't memorized the double angle formula, I haven't memorized the sum to product formula, I haven't memorized the product to sum formula, and the reason I haven't memorized all of these is that I have a good understanding of what they are and how they work. For example, take the double angle formula. Now you already have the sine addition formula, and when you know how to add two angles together and take the sine of the sum of those 2 angles, then it doesn't matter whether those angles are different or the same. And when the angles are the same, obviously you have the double angle formula. And I think if you teach these connections, if you have textbooks that focus on these connections, on these sort of skills of just reasoning through things, then you would be able to teach math and learn math a lot more easily, because you would be able to have a math textbook that teaches understanding of the subject instead of just formulas. And obviously, I want to say again that I do not blame teachers for this at all. I think teachers have a really tough time in this situation, because this is what the textbook is saying, and this is what the textbook is focusing on, and these are what the standards are focusing on, and the SATs are focusing on. And when you have 1 year to teach 1.5 textbooks of these, and you're teaching, and you have to make sure that students are ready for passing whatever standards that they need to pass for the standardized tests and the SATs and all the college prep. And I think honestly that all of these standards are really arbitrary and really just random formulas that I think do not encompass what math really is at all. And I also wonder where the accelerated course ideas came from, because the idea of an accelerated course really seems to go against the principles of a lot of the teachers that I have read about who started the Common Core ideas, because the idea of teaching advanced math should be that you go more in depth to concepts and you teach more problem solving skills and more reasoning skills and more of the same concepts, but what more you can do with these concepts besides just repeatedly applying the formula to different practice problems. And one of the things I would like you all to take away from this is that this, to me at least, this is not what I think of math at all. I don't think this is what anyone who considers themselves a mathematician thinks of as math. What I think of as math, and I do realize that this is more of a controversial idea, is the problem solving and reasoning skills. And I think of math, I enjoy math because of its beauty. And I understand that it's difficult to enjoy a concept because of its beauty when there's so much understanding that you have to get through to see the beauty. But here's what I see in math. I see the problem solving skills, I see the reasoning, I see the connections between different concepts that are seemingly unconnected. When you see a problem that seems like it's completely in one field and about one topic, but then suddenly you make the leap and you describe it slightly differently, and you make the connection that you can solve the same problem by solving a simpler problem in a completely different field that you know really well, and you know how to solve, and you see how all of this universe of math is so interconnected and so logical, and how you can struggle to solve a problem, but in the end, it's not about whether you know the formula or whether you entered the number correctly. It's about trying to reason through it and trying to be up to the challenge and trying to develop your skills. And I think part of this growth model, or I don't know if I want to call it a growth model of math, but part of this model of math where you're looking at problems and you're trying to challenge yourself to solve it, it creates a sort of mindset that you can solve a problem that looks challenging to you if you put enough time and enough effort, and you don't have that in these classes. You don't have that in problems where either you know the formula or you do not. You know how to plug in numbers to this formula, or you have the incorrect formula, or you have the wrong decimal place, and these are the only errors you can make because there are no errors in problem solving when there is no problem to be solved. And one of the things I have seen, and I'm pretty sure many of you have seen, is that a lot of you start to think that you're not math people, or you're not smart enough for this. And I disagree, because I think that this is not math, and I think that the memorization of formulas is not something that anyone should be tested on or anyone should be valued on. So what is my solution to this? Well, I have a few proposals. I have no idea how these would get implemented, or how these would achieve enough of a status to get implemented. But there are two things that I would like to see in the future of math education. And the first is obviously problem-solving skills. I want to see more problems which do not require formulas. Maybe they don't require much mathematical knowledge at all, but they're just fun puzzles to solve. That means logic puzzles. If you've ever tried to solve the riddle of the man crossing the river with the goat and the wolf and the cabbage, or whatever those riddles were. More riddles, more games, strategy games, chess, Go, Rubik's Cubes, other puzzle cubes, things where you're thinking and you're trying to solve, but you're not looking at formulas or numbers necessarily, but you're thinking about strategy and you're thinking about mathematical reasoning and pattern finding. And I would also like to see that sort of reasoning incorporated with these formulas, where you have a trig formula, but then you're taught it not as a formula, but as a series of ideas. This person had this idea, and then that person had that idea, and then it looks like this when it's written like a formula, but the main thing to remember is here are the general ideas about it, and then here are some problems, and see if you can apply these ideas. And sometimes it may be difficult to apply these ideas, but the point is that you're challenged and you're trying and you're figuring something out about it. And I think a very good analogy here is that I used to be someone who really hated history. And I never saw the point of history, because I always thought it's just you memorize some names, and then you memorize some dates, and then you memorize some more names and some more dates, and it's not really doing much. And then I started to talk to some people who really liked history, and I saw that one of the things that they kept telling me is that is not really history. That what I'm looking at is something that just no one who likes history, or I don't want to say no one, but not many people who like history do it because of memorization of names and dates. The point of history is to analyze what's happened in the past, to look at what caused it, to make sure that if it's something that's terrible, it doesn't happen again, to look at the factors that influence other factors, to look at the ways that we got to today. And I think the same can be said about math here. It's not just the formulas, it's the reasoning, it's the ideas that came to today. Why do we use a base 10 system? Well, because we have 10 fingers on our hands and people like counting with their hands. We learned today that 0 is a number just like all the other integers, but 0 took so much longer to implement than any of the other numbers. It was a representation of the void to some cultures. It was almost a religious heresy to some religions. There were so many interesting things that happened both in the history of math and in the logic of math, and neither of these are getting taught in math classes, and I wish that they were. So that's the first thing that I wish that was happening in math classes, is that logic and reasoning were combined with these formulas. And I understand that formulas are important. You can't get very far in math without learning some definitions and some formulas and some ideas, but I wish that they were taught as ideas, and I wish that they were taught in combination with other things that required less formulas, other games and other puzzles. And the second thing I wish for in math is that none of these reforms are ever going to be permanent, and we're going to keep changing and going back and forth, and no single reform is going to fix all of math. Instead, what we need is a culture of change, and a culture where math curriculums can be improved. And I think one of the things that needs to happen is that you need to have more collaboration between teachers, students, and these textbook writers. And you need to have more competition between these textbook writers, where the textbooks are actually trying to teach material that is important to students and material that students enjoy, instead of just repeating each other and plagiarizing each other and not teaching anything interesting in the process. And I don't know how that would happen. I don't know how you would create a culture of improving and feedback in the textbook industry, when the textbook industry is so much an industry instead of a tool for students and teachers to learn and to help each other. But I hope that it can happen, and I have hope that it will happen in the future. Anyway, thank you for listening to my rant. I know it got really long, but hopefully you learned something and hopefully you enjoyed it. Anyway, see you next time!